Have you ever played with kinetic sand? This magical substance is soft and fluid-like, but at the same time ideal sandcastle building material. So, what makes kinetic sand so special? You're about to find out. We can start by asking what exactly is kinetic sand. Kinetic sand is a mixture of 98% of regular fine sand and 2% of magic. It's these 2% of magic that we are going to focus on today. The magic in kinetic sand makes regular sand behave somewhat like wet sand, but at the same time it seems to have more elasticity and it shows different behaviors under different amounts of pressure. The substance responsible for the magic that gives the sand this behavior is polydimethylsiloxane, more commonly known as PDMS. And what is PDMS? This substance is a type of rubber-like polymer, which is part of the group frequently referred to as silicons. PDMS has a wide range of applications, from contact lenses to shampoo to popular food chain chicken nuggets. There are many different types of PDMS due to different chain lengths. The chain length of the polymer is responsible for a lot of the properties like viscosity and stability. For example, the longer the chain, the higher the viscosity, and that changes the kinetic sand in terms of elasticity and density. With higher viscosity, we get higher density and higher elasticity in the sand. Here we can see sand mixed with PDMS of different chain lengths and how they behave when applied the same amount of pressure. The one that mimics kinetic sand the best is the one with a dynamic viscosity of 30,000 kilograms per meter second. If the viscosity is higher than that, the sand gets too dense, and if the viscosity is lower than that, the sand crumbles easier. We mentioned before that the sand has different behaviors if applied different amount of pressure on it. This has to do with the shear modulus of the sand. When applied stress on an object, the object will deform. The applied stress per unit of area is the shear stress, or the symbol sigma is shown, and the amount of deformation is the shear strain, or the symbol E as shown. For small changes, E is approximately equal to the angle theta. The shear modulus is the relation between these two quantities and is therefore a rate for the elasticity. Since sand is not viscous at all, the elastic behavior of kinetic sand comes exclusively from the PDMS. When we zoom in on kinetic sand, we see that the grains are connected by PDMS bridges the same way water connects the grains in wet sand. And since the shear modulus of PDMS is quite high, kinetic sand has a unique flexibility. When applied force slowly and on a big area, the sand has time to move out underneath the pressure and will flow like a liquid. When the same force is applied by a knife, the bonds will break under this concentrated and quick force, so the sand will behave like a solid. Like we said in the beginning, wet sand somewhat behaves like kinetic sand, but not entirely the same way. As you can see, wet sand falls apart more easily and it's less soft due to the lower viscosity of water compared to PDMS. The grains in wet sand are connected by water bridges, and because of that, some properties of kinetic sand are mimicked. Like when you cut wet sand, it does behave like a solid, but if pushed slowly, it won't flow like kinetic sand does. Now that the magic behind kinetic sand is revealed, just a little warning. Even though this kind of sand is not toxic and children-friendly, do not eat too much of it. There are records that show that at least one dog died.